Total candle power. In olden days, the standard describing the brightness of light sources was a candle made with a particular type of wax and wick. This lives on in the name of the International, or SI, unit of measurement for luminous intensity, the candela. At NPL, Teresa Goodman has helped create internationally agreed definitions for light measurement that are used by her and many others to find out the total visible light output of light sources so that we know which light bulbs to buy. Let's get this clear. In this experiment, we are talking about the total power, heat and light from the candle. This is different from the labelling on light sources like torches that say, "This torch has 1000 candle power," which indicates it produces the light of 1000 candles.
What does this button do?
As it burns, a candle flame transfers chemical energy into heat and light energy. This type of diagram, a Sankey diagram, shows proportions of energy transferred. We can see that a candle generates 2000 times more heat than light. It is a very inefficient light source. To find the total power of a candle, we need to measure the mass of wax burnt and the time it takes to burn. You will need adult supervision as there's fire involved. Candles are hot and shouldn't be left unattended. A new candle or tea light and something to light it with. Some kitchen scales, a clock or timer, and something to write down your results. This is what you do. Use the kitchen scales to find the candle's start mass in grams. Write it down. Start the timer or note the time when you light the candle. Don't leave candles unattended, so keep an eye on it. After 2 hours of burning, blow it out. Use the kitchen scales to find the candle's end mass in grams. Include any wax that has spilled, as we only want to count wax that has burnt. Here are my results. My start mass was 14 grams, my end mass 8 grams, and my burn time was 2 hours. Here's the quick way to calculate your total candle power. There's a more involved step-by-step version at the end of this video. Put your results in instead of mine when you do your calculation. Total power equals candle start mass minus candle end mass multiplied by 12 divided by burn time in hours. The number 12 is a special conversion number that comes from the number of seconds in an hour and the amount of energy that you get in a gram of wax. When doing the calculation, remember to do the part in brackets first. My result was 36 watts. After you've done your experiment and calculated your total candle power, please share your results with us using the online form. Is 36 watts a lot? In your house, LED light bulbs typically transform 6 watts of electrical power into light and heat, though they produce less heat and more light than candles, which is why they look brighter. Here's the Sankey diagram for an LED light bulb. The arrow for light is much bigger than for the candle. And the eye doesn't see all parts of the light spectrum with equal efficiency, which is where the International Candela unit comes in, converting watts of light power into lumen values. The conversion is not simple, as the eye is much more sensitive to green and yellow light than blue and red light, as shown in this graph. Lumen values are given on light bulb box labelling to indicate total lamp light output. The most powerful item in your house is probably the boiler, which burns gas to heat your house and provide hot water at a whopping rate of 30,000 watts. That's about the same as 1,000 of my tea lights. Stay tuned if you want a slightly longer step-by-step version of the calculation. It isn't too complicated.
Yay!
First, calculate the wax used. Wax used in grams equals start mass in grams minus end mass in grams. Calculate the energy transferred. The joule is the unit of energy. As 1 gram of wax burns, it transforms about 43,000 joules of chemical energy into heat and light. So, energy transferred in joules is equal to the wax used in grams times 43,000 joules per gram, which gives us the result of 258,000 joules. Calculate the power of the candle. The watt is the unit of power. When 1 joule is transferred in 1 second, we say the power is 1 watt. We measured time in hours, and there are 3,600 seconds in an hour, so that's why that number appears in our calculation to convert hours to seconds. Power in watts is equal to energy transferred divided by the burn time in hours multiplied by 3,600 seconds per hour. And there's my result. So my candle has a power of 36 watts. Thanks for watching.